So thank you again. Thanks for everyone coming. So I think I'd like to start with if you're here and if you're interested in the work of effective altruism, I think I would assume that like me, we're pretty big on making an impact. I think when we talk about the upsurge of technology and the study of algorithms and the study of bias and combining them together, it's quite easy to say that whatever research being done in this area would make an impact, which is partly true, but I think the challenge would come with how to act on the research, which is something that is challenging for us as researchers as well. So what to expect from this keynote is that I'm looking at the issue more from the sociological and public policy perspective than from the algorithmic and technical perspective. And this is because that is my domain of research. My work as a researcher comprises lots of policy and theorizing the social impact of algorithms. I'm not a programmer, I'm not a computer scientist. And if you are studying computer science, I am very sure that you would be more of an expert than I am in answering more of the micro level, bottom up technical issues. Secondly, my research focuses on the gender bias in automated decision making. But in this particular talk, I will discuss the general implications on social issues. And this is because this keynote is targeted to creating more awareness in terms of how algorithms would can repeat or exacerbate bias, the existing human biases. I'm also focusing on algorithm model. So I would acknowledge that there is a wide variety of algorithmic biases out there, but here I will focus on those without intentional mitigation to bias. So that I would exclude the talk about causal models or explainable AI, etc., etc. I would touch upon these things just a little bit, but that's not the focus of the presentation. And this is because there's still a lot of demand towards the high accuracy of algorithmic models without intentional mitigation plans, and I will touch upon that later on. So the question that I would like us to think about during this talk is mainly this: what is algorithmic discrimination and what does it mean for inequality? And I know that this question is very open-ended and very broad, and I don't think that there is one answer to this question. I don't think anyone has managed or successfully answered to this question particularly, but I think it's very good to reflect on. So first, in answering why why we talk about the question that I asked, the roadmap of this talk is, firstly, I would like to talk about why is there an increasing demand for AI, and in answering that, I would like to touch upon the how do algorithmic models work in a very simplified way, and then the types of algorithmic biases and the sources of biases. And I will look deeper into my own research, looking at the automated decision making in labor force, specifically how it impacts gender inequality. And lastly, algorithmic governance problems. So this is more of the response side of the issue. So how algorithms would redefine the meaning of legitimacy, transparency, and accountability, and what does it mean for the current human-centric discrimination laws. Okay, so to answer the first question first, this is how algorithmic models work in a very, very, very simplified way. So there is an untrained model, a model that is programmed by programmers, and then a set of data is fed into the model so that the model can learn and it becomes model training. Now it is, I think it is quite notable to discuss a little bit that there is different sources of data, different types of data I think the most common categorization of that is the supervised or unsupervised data. So supervised being humans have already categorized which data is good and which data is bad, and then they, put that into the, feed that into the algorithms, and therefore the algorithms know which one has been categorized good and bad. And of course, in that sense, they have captured the human decisions. And then the unsupervised models is it's quite raw. So the data is put into the, it's fed into the algorithms, and then they decide and they group them according to the patterns that they see. So that's very, very broad explanation of, supervised and unsupervised. And then it becomes a model training. So after the algorithms are being fed with data, they become a trained model. And then the trained model will be fed with new data, the data that you want them to assess, and they create predictions based on these data. So that's very, very simplified how algorithmic models work. So again, I'd like to acknowledge the different types of algorithms. There is so many. There are some that are more simplified. There are some that are more complex. But based on the very, generic and very broad explanation on how algorithmic model works, we could answer, why automation? Why do people depend so much on automation, and why do they love automation so much? And in a nutshell, this is why people like predictions. People like automation. It's because they summarize data. Data is complex and they summarize them. And then they can predict the future, and they can predict the results of interventions. That means when they predict the future, you could manipulate what's happening. What would the future look like if you do ABC? So in a nutshell, again, people like predictions because they don't like risky things. They don't like costly risks. They like to see what the future looks like, and they like to act upon it sooner than later. And this is why the use of automated decision making is often adopted in areas that are more risky, and mitigating risks would be costly, such as healthcare, public policy, and recruitment, because losing personnel is quite costly for the economic benefit of the company, and criminal justice. But this leads to the puzzle of algorithmic predictions, because much like any other big advancements, automation results in big consequences, and worse, they can result in big social issues. And this is not the things that people usually predicted would be happening back in, the first time automation started booming. Like, oh, what happened if there's like killer robots, and then we get to have wars with robots and things like that. And it's not necessarily that way, but it's the things that we didn't predict in the first place that is actually dangerous. And it's actually the racial disparity and gender disparity that we thought automation would be able to eradicate, but they couldn't. So that raises another question. If automation is made for humans, how human-centric are they? So I think it is fair to answer this question both from the perspective of the similarity and the difference between human thinking, human brain, and algorithms. So firstly, they are generally designed to mimic how we think. So much like human intelligence, AI captures patterns. They generally make associations and create predictions based on these associations. And most of the time, the associations are based on correlations. But if we study statistics, or if we've done research before with data, we should be familiar that correlations do not equate causations, and this is where it could create problem. So one of the examples to this is this data here. So this is data showing US spending on science, space, and technology, correlating with data showing suicides by hanging, strangulation, and suffocation. So as you can see that the data is correlated, but based on the legends, we should be able to tell that, surely suicides by hanging, strangulation, suffocation is not caused by US spending on science, space, and technology. But there are some data that are less obvious than this, and people like to still make correlational biases. We could see that a lot in politics, especially nowadays. I think Trump likes to mention the word Mexican and crimes in the same sentence, and that's because of statistical bias. But anyway, so this is the things that human bias can do, but this is something that algorithms are also not immune to do as well. And one of the examples to that is this. So algorithms can make correlational biases too. For example, and this is a very hypothetical example, by the way, if most successful lawyers attain high GPA and most successful lawyers play tennis, therefore the success of law graduate can be predicted by both their GPA and whether or not they play tennis. This is one of the most commonly used examples. Imagine if this is this correlational bias being applied in recruitment, then the success matrix is quite flawed. And the consequence of this is quite severe, actually, even though this is the hypothetical example. And we could see one of the real world cases with correlational bias is the LATANYA-SWEENEY case. So there's an African-American female professor at Harvard University called LATANYA-SWEENEY. She Googled her own name on Google, and just another ad showing up, and it says LATANYA-SWEENEY arrested, 1, enter name and state, and 2, access full background checks instantly. Of course we don't know what's going on in the algorithms of Google that make these things come up, but we know that with all ads happening in whatever screen we have is micro-targeted. We are targeted based on demographic traits and how some demographic traits correlate with some behavioral patterns, and therefore these things come up in our screen. And it is safe to assume that it's because LATANYA-SWEENEY is African American, and therefore there is a higher correlational points between criminal rates and the number of African Americans who needs to access their full background. And this is one of the examples to the correlational bias that algorithms can make. And we have seen the similarity between human bias and algorithmic bias, but the difference being, and I think a lot of us have understood this, but unfortunately, unlike humans, algorithms are blind to political, historical, and societal context, and and their own biases. So we can, as humans, self-reflect and be aware of our own bias, but unfortunately, algorithms couldn't, or yet to be able to. I don't know. So that leads to another puzzle of algorithmic predictions. Oh, that's a typo there, sorry. So the gap between how contemporary AI works and how people work is getting wider. Unlike handcrafted statistical models that use human relatable concepts, machine learning models are derived automatically from data and are not designed for human consumption, such as deep neural networks, which so often contain hidden variables. So we can see this is from one of the readings that I love by Tim Miller. He's also a lecturer at the University of Melbourne. The development of AI lately is getting more complex, and it's quite deliberate. So the complexity of AI is not something that programmers do and then like oh no, what just happened there? But it's actually intentional, it's deliberate. It's because there is a pride that comes with this, which is higher accuracy. So there's a claim, there's a large consensus in the scholarship of machine learning that the more complex they are, the higher accuracy that they can get for their predictions. And it's quite logical. It's because the less human intervention, we're pretty slow in responding to things, and they can update quite fastly and without without much regulation would be able to tackle problems more swiftly. But then the question becomes, how are we sure that these predicting, concluding, and determining variables comply to what we humans perceive as fair? And the very, very, very short answer to this is, unfortunately, in many cases, we can't. And it's because algorithms are not designed for human consumption most of the time. I'm not saying it's always that way. And because it's made very complex and that they learn at task, that makes it very, very hard to know which variables that they use in making predictions and to what extent they are considered as discriminatory. But I think it's still valuable to look at the common types or sources of biases in order to mitigate these biases. And that is why I'm going to expand a little bit more on that. And note that there are lots of theories on where the biases come from and the sources of biases, and sometimes they overlap with each other. And I'm not here to debate those, but I'm trying my best to summarize these into three. And again, these three can kind of overlap sometimes, and they cannot be separated from one another. But I hope that could enlighten our understanding more on that. So the first one is bias in the data set. So as you can see, early on, we talked about how algorithmic models work in a very simplified way. They were being fed with data set. Now, data set, unfortunately, is not neutral. Data set is not neutral. It's anything but neutral. And this is because if data is the reflection of our society or existing society, then it can never be neutral, because the society is not neutral. The society is biased. The society is discriminatory. And therefore, data is never neutral. Of course, there are ways to mitigate this. For example, you try and control the level of balance of representation within the data, but then there would be human intervention in that, and how biased the humans are is kind of also questionable. And this is something that there is still tension in that. Every time we do research, in any type of research, we always think about that. And I don't think that there is a silver bullet, a level of like human intervention or a level of rawness of data that is a fit to all. One of the examples to the biases of data is this. So this is called word vectorization. So this is a very hypothetical example. If we extract the data from the big data, which is the data I get from internet, for example, hypothetically, if they do, then the algorithms could capture these. So an article from the conversation, the title says why the US still hasn't had a woman president. And then it captures from the Jane Austen's Pride and Prejudice text cited in that link, as the daughter of an attorney, Mrs. Bennet married up when she captivated the landed Mr. Bennet. Ergo, women and daughter are learned to be semantically similar, and therefore there will never be a president, or there will be lower probability of them being president. So stereotyping will thereby occur. And the consequence of that is quite severe. again. So this is one of the cases that I could come up with, the job micro-targeting. So Bogen's experiment in 2019, he tried to observe the job vacancies that are being advertised on Google and Facebook. And apparently he found that supermarket cashier role is advertised to a population of 85% women, a taxi driver role to 75% Africans by race, not by geography, and high salary executive roles to men 6 times more than women. If you are also familiar with this case, this is quite a prominent one. So in 2014, the Amazon, the big tech company, Jeff Bezos, they created hiring software to assess the suitability of candidates for their own company. And they were being fed with the existing internal data of their own workplace over the past 10 years. And it turns out that the algorithms discriminated against CVs that contain these words: all women's college, female, women's chess club, and any keywords that suggested these CVs are from women. Of course, they turned it down, I think 2 years after, but still case in point. Secondly, bias in the system. So this is quite related to the previous one. So it's usually, this is referred to as the system because it's like statistical bias, and it's how the algorithms work in general. One of the examples to this is the Compass Republica case. So Compass is the correctional offender management profiling for alternative sanctions. So the algorithms were commonly used in the US to guide sentencing. They predicted the likelihood of criminal reoffending, so recidivism. And in 2016, ProRepublica is it's almost like it's like a journal or like a news where they produce articles, but they are based on rigorous research investigating the problems with the institutions and with systems. They released a research claiming that Compass is racially biased. So not only that they predicted African Americans to be more high risk than white Americans, but they actually overestimated the risk of recidivism of African offenders, but underestimated the risk of recidivism of white Americans. So they compare the rankings from the predictions in comparison to the 2 years actual reoffending numbers. And this is a similar case, PredPol. So this algorithms is being used in some US states. The algorithms are used to predict when and where crimes take place. So the aim is, again, to help reduce human bias, and this is quite common with algorithms. In 2016, the Human Rights Data Analysis Group claimed that they unfairly target certain neighborhoods. And if you know, in the United States, neighborhoods are very, very segregated, linked to race. So this is completely based on statistics. And lastly, there is bias in existing human decisions. One of the examples is this one. This is quite similar to the Amazon case, actually. So St. George's Hospital in 1980, this is a medical school in the UK. They made admission software. Apparently each year they rejected approximately 60 applicants on the basis of race and gender. And again, this is not because the algorithms introduced their own biases, but it's because of the previous human decisions. So based on these 3 biases that I talked about, my team and I, we conducted a research specifically looking at how these biases occur in recruitment, especially with Australian workforce. So this is basically the research that I did and currently still doing. So there are still some things that I can't talk about, but I hope we can still discuss something meaningful. So this is how we designed the research. First attempt, we picked gender balanced jobs, and apparently in Australia it is accounting jobs and financial officer jobs. And we made resumes, 2 resumes, actually 1 resume, but being copied into 2. So it's like completely identical resumes, but we only manipulated them with gendered indicators as variables. And these variables are gendered names. So, okay, so my apologies for being very stereotypical in this, but we should be very binary in determining men and women in this case, not because we don't value the non-binary, but it's because the society is still very binary, and we have to manipulate them based on, if we want to look at the stereotypes happening and being repeated in the algorithms, then we need to do that. So gendered names that are obviously stereotypically tied to men and women, like James and Jane. And then gendered keywords. One of the key findings from our literature is that, and this is quite interesting, that men and women use different words to describe themselves and describe what they do. And most men would describe themselves to be quite directive, so they would use the word like leading, directing, and acting on something, while women would use words that are more agentic, so like collaborating or facilitating. And then we also introduced parental leave gaps. And this one is just for fun because we wanted to know what would happen if we introduced 5 years parental leave gap, and what would happen between men and women in that sense. And then we manipulated these things and submit them into job roles from different from different companies, of which decision making, or at least shortlisting decisions, are made or controlled by algorithms. And we observe the outputs based on the shortlisting decisions, so looking at positive responses and negative responses, and also the online engagement indicators. So if we look at, LinkedIn or seek.com, if we make our own profiles, we could see how many people view our profiles and things like that. Yeah, so this one's. So these are the outputs. So with the gendered names, 40% men get positive responses. Sorry, no, that's not true. Out of all the job that we apply to, 40% of them, no, I'm sorry. So this is the percentage of positive response in contrast to how many jobs we applied. Okay, that's the right one. So let's say we applied for 100 jobs, we get 40 yes. That's what I'm trying to say. And then for women, we get only 2 yes. Whilst for negative response, the men get 13 yes, and women get 40. Oh, sorry, the men get 13 hard no, and women get 40 hard no, and the rest of it is no response. For gendered names plus parental leave gap, it's the same for positive response, only 2%. And for negative response, for men, we get 32%, and women 34%. It's not that much. But this is where it gets devastating. For gendered names plus gendered keywords, men get 48% in comparison to women getting 0. For negative response, men get 8% hard no, while women get 62%, and that's more than half of the jobs we applied. And keep in mind that these are the exact same experiences, the exact same qualifications and educational background for all of the 3 experiments as well. This is also from our profile in one of the online recruitment sites. We could see on the left, it's for the men, and the right for the women. We changed the names because we got caught. Anyways, we could say that for the men, we got the badge there. You may be a strong applicant. It says using data based on employers' past behavior, the default resume in your profile, and other factors. The algorithms predict you may be a strong applicant for this role. Well, if you can see on the right side, Sarah didn't get any of those. Those blank white box there is just me trying to censor the name of the company. But we also found caveats to our own research. So our claim is only limited to the majority of decision is automated. So we couldn't understand, or we couldn't identify the levels of human intervention in the outputs. So for instance, if Jane and James being ranked 5 out of 5, it's still in the decision of the human recruiters to make the phone call if they only need one person. That's like the example. And then we were only focusing on the input and output of the research, but we couldn't understand what's going on in between and what's being targeted, what variables actually were being targeted in that sense. And our claim was limited to a specific industry, not across different industries. And hence, we don't know the why. So we couldn't formulate a specific solution on that. So that creates another puzzle of algorithmic discrimination. To what extent decisions made on the basis of gender are discrimination on the basis of gender? And as we can say that algorithms make micro decisions leading up to the prediction, and to what extent a decision made is a discrimination. And this calls for interdisciplinary research, which is the research that I'm currently doing. And I'm also doing that next year for my PhD. The boxes on the left is the caveats from my previous research. And these are the things that we can further look at, which is looking at the levels of human intervention. So trying to control that part, and then looking at the explainability of algorithms. So there are already some literature and some scholars that are specifically looking at explainable artificial intelligence. But there is a huge tension between being able to explain what's going on in AI for accountability and accuracy, as what I was saying prior. And then expansion of samples. So we could expand across industries. So looking at the male-dominated jobs, female-dominated jobs, and gender balanced jobs. That way we could see whether they are not only favoring men, but favoring those that algorithm thinks is gender suited. So if, for example, women are dominating the nursing job, then would they favor women in that part, in that area? And if that is the case, then they are repeating the gender roles, not just favoring men, for example. So from there, we could look at the why of discrimination, and therefore we could theorize further the sociological inferences and the level of discrimination. And then we could translate different theories into applicable algorithmic process or outputs, and finding the fair and effective balance between the two. There have been suggested responses in this area. I've mentioned explainable AI. There is there are some theories in public policy arena how to translate ethics into systematically applicable framework for algorithms. But unfortunately, there is still no structurally implementable policy being done. So far it's only like either very, very up there, like very, very broad, or it is very, very micro level algorithmic process and outputs, and it's just a matter of like ticking the boxes, but there is no comprehensive public policy being translated into algorithms as of yet. And from the law perspective, thinking beyond human decisions or how to make human accountable over AI in the most possible way. I hope this is very helpful for you. I know that some of these are very, it's either very technical, it's very broad. It's really hard to come up with things in between when it comes to algorithms and bias, but I hope it's very helpful. Thank you for the time. Any questions I could answer? Thank you.
Yeah, wow. Thank you, that was amazing. Definitely an eye-opening discussion there. So we'll jump into a couple questions. So if you have any, just drop them in the chat and I will just, yeah, go from there. I do have a couple prepared. So in your paper, you highlighted that accountability in algorithms to be an important part of reducing discrimination. Do you believe there should be more regulation beyond that, such as in the construction and usage of algorithms? So requiring like algorithms to abide by a certain ethical standard or potentially prohibiting automated decision-making for certain outcomes?
A very short answer, maybe yes. But the implementation of it, it's very, very, very hard because I think algorithms is very like contextual, right? You know, the use of predictions is very contextual. Like, for example, you can act upon a prediction quite easily in some industries, but not in others. For example, if in recruitment, you can actually act upon predictions very, very easily. You look at how successful you can be, you look at the risk of quitting the job, so you don't hire them. And that's considered as, it's not harmful. But in the case of recidivism, for example, you can't just predict that this person is high risk and then you know, you arrest them before they're offending. So I think the many layers of like how algorithms actually work and in which industries make it very, very hard for public policy to respond to this. And yeah, and there is, I don't think that there is a one answer to this. And it's really tough to answer that question. But I think that people in law and in public policy should really rethink this issue, not just from human-centric perspective, such as, you know, regulating what humans can do, but really, really try and redefine what discrimination and fairness means in the age of algorithmic decision making.
Yeah, definitely. I think Aisha had a question to ask.
Yeah, thanks so much for your talk, firstly. That was really interesting. I'm actually a computer science student, so being able to see more of the sociological perspective of that is something very enlightening and something I'd like to learn more about. So I think you made a really interesting point about do algorithms and machine learning algorithms actually predict a correct outcome? Sure, they do predict things, but do they predict something that's accurate? And something that I read about recently was about LAPD's and Palantir's facial recognition police department that they were using in police departments. And a really interesting point that I read in an article was that it doesn't actually predict who's going to commit a crime, but it's just going to predict who's going to be arrested. And obviously that goes into a self-fulfilling cycle. I'll actually link the article right now. It was on MIT Technology Review, if anybody's
that'd be great.
Interested. So I feel like I'm very interested in this concept of how do we mitigate bias in algorithms as well. But one problem that I've had is that it's really hard to convince people that it's a problem. And a lot of times people don't even see it as a problem. And there are so many people that I'm friends with on campus, for example, but if I say something, if I ask them something like, why do you care so much about AI, or why is machine learning interesting to you? Most people will just say, oh, it's just something interesting and cool and I like math, which is fair enough. But like, how do you kind of, I guess, overlay the fact that this is a social issue with some kind of pragmatic veneer, if that makes sense? How do you incentivize people to sprinkle that idea that, hey, we might have a problem with this algorithm before it actually happens. Like kind of like with generative adversarial neural networks, how Ian Goodfellow, when he worked on his research, he didn't think things like deep porn and fake nudes would be an issue that primarily target women, by the way. And that's like, it's not like he intended for it to be bad, but you know, if people were there who, like the type of people that it affects now, if they were there during that research, they could have pointed out and been like, well, you could make fake images of that. So how do you actually, like, would you have any insight on how do you actually incentivize companies and people who make algorithms to care about these things?
I think I'm quite grateful that lately there is an upsurge in awareness, especially since the Netflix documentary called Social Dilemma, I think. And there's a lot of people who are actually getting more and more interested about, you know, these biases that occur within the algorithms and within data itself. But there is still like, it's something, I think people still perceive it as like, well, algorithms is like a world out there that we can't reach, we don't understand. It's like quite, like we're quite separated from it. So the impact is not, it's not as seen as we can see, like, you know, reality. But I think I can see that there is a growing concern to make people more aware. To be honest, I don't know. And I think I would love to see people more aware. And that's why it's, and you know, every opportunity I can talk about this, I would. But that is a very good point you're making, Aisha. The answer is, I don't know.
Yeah, great. Angus has a question. Does AI have the potential to be less biased than humans and society? And I'll expand on that. Do you think that algorithms could help reduce societal biases and discrimination?
Potentially it could, and potentially it has. I mean, not reducing or like not eradicating bias, but we have seen in some like use of algorithms being done to actually analyze the levels of human bias already. Like I've done research on statistically trying to quantify the biases in human decisions when recruiting people. And we could see that there are bias, and therefore we could make a concrete policy, for example, maybe putting quota for gender, for example. And we could do that because we are aware, and that is because algorithms did it for us and quantify it for us. I think there is a possibility in that, and I think we could enlarge that potential. I'm pretty sure we could, but I think the levels of how they can do that is quite limited, I think. Yeah, I hope that answers the question.
Yeah. Yeah, it's definitely an issue there. Calvin asked, do you have any thoughts as to how to make sure that the people developing the algorithms and the decision makers who are choosing to deploy the algorithms are aware of how to minimize unwanted bias in their algorithms?
Is there anything that is made or programmed? Is there anything that is programmed by humans that are not biased? I think that's the question. I don't think that is. I don't think that we could eradicate bias to zero. To minimize it, I think we could. But it needs lots of progress in going there. I think it's also a constant battle as well. Yeah, like constant self-reflecting. Yeah.
Could also be an issue of representation in tech and those who are creating the algorithms.
Agree. Yes.
I think Patrick had a question that he wanted to ask.
Thanks, Max. Sheila, loved the talk. Super fascinating.
Thank you.
Just on your point when you were talking in your speech about how biases in recruitment might, for instance, discriminate based on race or gender, and it might, for instance, predict that they won't want women for a particular job or industry. When people are using these recruitment bots, how much do people actually understand about the judgments do you think that the bots are making? Like, if you're a HR officer or a recruitment officer, are you able to actually go into the computer or the system and see how it is discriminating against different groups? Or is AI at this point kind of like a black box where inputs are being fed in, outputs are coming out, and we don't know what's happening in the middle?
Most of the time it's the latter. I think if someone from computer science here, including Ayesha, would like to expand on that more, but yeah, I think it's more often the latter, when we can't really open up the black box and see what's going on inside and what sort of variables are being tied to the success metrics. But there are, I think it also depends on how complex or how the success metrics are being used as well. For example, if I have mentioned earlier in this talk where if the algorithms are being fed with supervised data, so the humans have already determined which one is good and which one is bad, for example. But then again, the human bias can come through that already. So yeah, I think to answer the question, it's still very, very hard to determine to what point they actually create those biases, and to what point the correlational to a point the correlational points that they make between one attribute to another is actually considered discrimination as well. Yeah. And to answer your first question, I don't think, and I'm very sure that lots of companies actually are not aware of this. I did a research for a private sector on this issue whilst they were using AI, not AI, but like machine learning, automated decision making for their recruitment. And I brought this up to them and they were shocked. And I was using data. I was using the resumes from the people that they have all hired. So they are all successful, but the algorithms still are gender biased against them. So it's still like, yeah. So I don't think that many companies are aware of this.
Wow. Thank you. That is, yeah. That's terrifying, but I guess it's good that we know that.
Yeah, there was a joke in my project team as well. Like when we saw the findings and then we were like, you know what, if you're a woman, just get your men friend to write resumes for you, because it's you know, it hires up your risk to like 40%. That's crazy. That's a huge difference.
Wow.
Anyways, that was a joke, by the way.
Yeah.
It's not the moral lesson of today.
Yeah. Crystal asks, what are the policy mechanisms and interdisciplinary research areas available to reduce AI biases?
Sorry, is this the last question? Oh, I mean the question on the chat, or?
Yes, I think so.
I don't really find it. Would you mind repeating?
Yep. What are the policy mechanisms and interdisciplinary research areas available to reduce AI biases?
Oh. You mean so far? Like the ones that have been done so far, or?
I guess potentially new research that people might be able to go into, or just maybe areas of like neglected research that someone in this call might start.
I think I don't think that there would be such thing as enough research being done in this, because I think there will be still like societal transformation going on, and you know, the advancements with technology is crazy and it's very fast paced. So there will be so many things changing within that area. Even the new models that are being raised up in the scholarship of machine learning lately have been like, there is a lot being suggested already, but none of them actually is being implemented and like is considered as like the ultimate solution to everything. So I don't think that there is such thing as enough research. So yeah, come on board and do research. It's yeah, the opportunity and the prospect with this type of research is crazy. It's out there. It makes you confused every time, but it's good. It's challenging, but it's good.
Yeah, definitely. Lauren asks, is statistical bias something that can be simply fixed with better algorithms, better predictions of whether Black offenders were going to re-offend, to use your example, or is there an inherent problem? I'll also just repost that in the chat.
I think, okay, it's an interesting question. I think it comes back to the tension between like being able to explain what's going on in the AI and the accuracy of prediction again. So there is a lot of, so if I am to answer that question, then yes, there are some algorithmic models that have been suggested out there in the scholarship in order to be able to provide more accountability mechanism to these things. But why it is not, why it does not act as a silver bullet is because you risks lowering the chance of accuracy of prediction. But then again, like sometimes in some industries you need more accuracy, but in some other industries you need more accountability. So I think it's about where to find the balance between the two, contextually as well. Yeah.
Okay. I think we'll just do 2 more questions. So if you have any pressing ones, just drop them in the chat. From Kale, what do you think about affirmative action? Can it be applied to algorithmic discrimination?
Interesting question. I have read a literature that actually says that some companies have implemented this kind of software. So they have intentionally tried and make quota for women and group. So they make decisions based on, okay, I need 4 women, for example, and then they look at the success metrics of all the women and rank them for those 4. So yes, basically like affirmative action. So to answer that question, yes. If the question is being put further to why do people not adopt these everywhere, I don't know. I don't know the answer to that. I think one of the major reasons would be lack of awareness again.
All right. Yeah, definitely. I think that is everything. So I'd just like to thank you, Sheila, for taking the time to speak to us today. It was a super engaging discussion highlighting an area of AI that I think not a lot of people are really aware of, but will definitely have a real impact on them at some point in their life, whether they know it or not. I know I've learned a lot, especially in how like endemic discrimination can be in algorithms, and obviously how unaware a lot of people are, even those creating those algorithms. So yeah, if you have any more questions, you can contact Sheila on LinkedIn. So we'll put that in the chat again, as well as on the event page in a discussion post. We also highly recommend a podcast, Politics versus Policy, and her research paper, if you'd like to do further reading on this. If you want to stick around for a bit, we'll do a bit of a chat waterfall and ask you a couple of questions in the event, just like what could do better, what you really enjoyed and so on. And we definitely value your feedback. We also have one more event lined up this semester, Mental Health in the Developing World, which will be a discussion with Victoria Baranov, which can't recommend it enough. It will definitely be another super interesting and educational event. So yeah, thank you.
Thanks everyone.
Do we want to do the chat waterfall now, Max?
Yes. Oh, most people do.
Yeah. Oh, shit.
We can do a couple questions. So if you haven't done a chat waterfall before, it's just, we'll just give a minute or 30 seconds for you to answer a question. And then we'll just let the chat waterfall your answers. So firstly, what was your favorite part of the event?
Yeah, so just type in the chat and don't press enter.
Does everyone have those down? Just, yeah, press enter then. And the second one, something you'd like to have more of. All right, just when you're ready, just press enter there. Yes, amazing. Thank you, everyone. Yeah, I think that's pretty much it, guys. So I think, yeah, if you have anything else to say, we'll probably hang around for a bit longer, just chatting, or yeah, feel free to leave whenever you want. I think I'll just be able to